carrying on, somebody gets into the bath, then they are going, I'm aware this is terrible, then it's going to displace that amount of water. That amount of water has to move out of the way in order for Archimedes or whoever to actually be immersed in the bath. So where's that water going to go? He's pushing it out of the way. It's going to float out of the bath. Okay, now the amount of water that is pushed out of the bath is going to have the same volume as whatever is in the bath, so of Archimedes here. Now here, obviously it would just go on the floor in a puddle. That's not helpful. But if we had somehow had some really large tray, we could collect up the water that was spilled, put it into a measuring cylinder and measure off how much, what the volume is of that water, and therefore the volume of the object within the water, in this case Archimedes. So if this said 10 millilitres, if you remember from the volume lesson, that is equivalent to 10 cubic centimetres. Okay? And as I said above, we can measure volume in cubic centimetres. Okay, if it said, 15 millilitres, that's 15 cubic centimetres, and so on. Now I don't have a measuring cylinder here with me, unfortunately. That's all that equipment's at school. But what I can show you is something displacing water. So I'm going to fill this mug up with water. This is my object that I'm going to put into the water, and the amount of water that comes out of the mug into this tray, into this bowl, will be however much space that this takes up. So bear with me 1 second. I've tried to fill it up to the very top. Now I cannot drop this in. If I drop it in, some of the water is going to splash out, and therefore it's not really going to be very accurate measurement of how the volume of this. If I drop it in, it would be better if I could use string or something rather than my fingers, because if my fingers get in there, then some of the volume of my finger will take up some of the space as well. So if I do this as slowly as I can. Okay, probably could have done it better. Doesn't help that it floats. Didn't know it was going to float. But if I now take this out, just move this over here, then you can hopefully see that there is some water in here. And if I had a measuring cylinder, I could pour that into the measuring cylinder, see what the volume of it is, and that would be the volume of this smaller glass here. Okay, so that's how it works. Obviously I could use anything. The problem is, like I just showed you, is if something floats, like this ball will float probably. Yes, it does. Therefore, it's quite a lot harder to do, and I'll have to find another method. But if it doesn't float, then you can find the volume of it using Archimedes' principle. And that's it.